All right, here we go. This is chapter 7, day number 11. This is solving systems of linear inequalities. We're going to start out here first by defining what a system of linear inequalities is, and that is two or more linear inequalities form what we talk about as a system of linear inequalities. So that's going to be a combination of two or more inequality statements. A solution of a system of linear inequalities is an ordered pair, like x comma y, as written here, that is a solution, I want to emphasize here, to each inequality in the system. So how do you know whether or not an ordered pair is a solution? It has to satisfy being a solution to each inequality. So if there was two inequalities, you'd plug in x and y, those values for them, for both the first inequality and the second inequality. If there's four inequalities to our system, you would have to verify that that ordered pair is a solution not only to the first and second inequalities, but also the third and fourth as well. So let's take a look here and go through some graphs of what it might look like to solve and look at a solution set for a system of linear inequalities. I'm going to look at the first line here, and I'm going to recognize that this is in y equals mx plus b form. So the first thing I'm going to do is plot my 0, -5, which is my y-intercept, and then I'm going to use a slope of -3 divided by 4. So I'm going to go down 1, 2, 3, and to the right 4. I'm going to go up 1, 2, 3, and to the left 4. I'm going to draw this line in. I know that this line here is going to be dashed. The reason I know that it is dashed is because I realized last chapter, let's see if I can do that one better. I realized last chapter that if it is not or equal to, it is going to be dashed. I'm going to pick a test point, and again, I'm going to keep sticking with blue here because my test point I'm going to use is up here, and I'm going to test 0, 0. If I test 0, 0, I get the statement, is 0 less than -3/4 times 0 minus 5, is 0 less than -5. Well, I know that to be false, so that means up here it is false, which tells me down here it would be true. So I'm going to put little arrows here because I'm going to have to graph the second line and look for the intersection of those two shadings. I'm going to graph the second line here in red. This is in standard form. And when I go to find my x and y intercepts to help me graph here, I know that my x-intercept will be -6 because -2 times -6 is 12. I also know that my y-intercept is +2. Again, plot those points. This line here is going to be solid. The reason this line here is solid is because it is or equal to, and then again, we're going to have to come through and get a test point. So my test point here I'm going to use is, again, 0, 0. And if I use the test point 0, 0, I get is 0 times -2 plus 6 times 0 less than or equal to 12. Is 0 plus 0 less than or equal to 12? And we know that that is true, which means, again, we picked this point here. Now for the red line, it is true. So I know that I'm shading back towards 0, 0. And where those solutions lie are where the red and the blue intersections are. So that's the left and down from the blue line, and down and we'll say down from the red line. So now I'm going to darken that in and say that that shaded region is in here, which means any ordered pair in that region would satisfy being a solution. Let's take a look at problem number 2. In problem number 2, first line is again in slope-intercept form. So I'm going to plot my y-intercept at -5. And here I'm going to use a slope of 2. That means I'm going to be going up 2 over 1, up 2 over 1, up 2 over 1. I know, in fact, that this line, again, is dashed from last chapter, and we know that because it is a greater than inequality, and it's not greater than or equal to. And here we move into our test point. Again, I'm going to stick with this idea of testing 0, 0. And if I test 0, 0, we get is 0 greater than 2 times 0 minus 5? Is 0 greater than 0 minus 5? And we know 0 is in fact greater than -5, so this is true. And again, I'm going to just put arrows here to show that we are shading up and left of that line. I'm going to now get ready to graph the bottom line, which is again y equals mx plus b. So I'm going to graph 1, 2, 3 as my y-intercept, and then I'm going to go down 1 over 1, 2, 3, down 1 and over 1, 2, 3. This line here will be solid. I'm going to pick the test point for this line. Again, I'm going with 0, 0. We're going back to here. And I want to know, is 0 less than or equal to -1/3 times 0 plus 3? Is 0 less than or equal to 0 plus 3? Is 0 less than or equal to 3? Well, that is in fact true. So again, we're going to shade towards 0, 0 in this one. So now as we look at our solution set, we are shading left of the blue and down from the red. So that's down from the red and left of the blue. And again, we're looking for the ordered pairs that satisfy both inequalities. So all the points that would be in this region here would satisfy being solutions. I really like that we have multiple colors we get to use because it starts to make, showing our solutions a little bit easier to follow. The next problem here, if I go to graph this line, I'm going to use a little key code. I'm going to graph this one, and it says y is less than or equal to 3. Well, if I remember this is going to be a special type of line where y has to always be 3. And if I take a look, that's going to be like 0, 3, and 1, 3, and 2, 3. And I know this line is solid because it was or equal to. And if I pick a test point, is 0 less than or equal to 3 when we test 0, 0? And that's true. So we know on this line we're shading down. When I go to the second inequality here, slope-intercept form, I'm going to start with the y-intercept of 1. I'm going to go down 1 and over 1, 2, 3, down 1 over 1, 2, 3, and I am going to make this line dashed. The reason it is dashed is because that is a greater than. It is not greater than or equal to. And when I test this here, I'm going to again test 0, 0, because 0, 0 is going to be right in here. And we get, is 0 greater than -1/3 x, where x is 0, plus 1. Is 0 greater than 1? Well, that's false, so we know that we need to be shading up from here. Again, we know that it is up because we're talking about this point that we tested here as being false below, so the solutions need to be above. I'm going to erase the word false as not to clutter my graph. Last but not least, I want to come to this bottom line. This bottom line is in standard form. When it is in standard form, easiest thing to do is to find my x and y intercepts. My x-intercept is 3 because if I cover up the 3y, 7 times 3 is 21. And if I plug 0 in for x, my y-intercept is 7. So I'm going to plot 3, 0 and 0, 7. This line is going to be solid. And again, if I go with my test point, I'm testing 0, 0, which is again over here to the left of that line. And we get is 7 times 0 plus 3 times 0 less than or equal to 21. Is 0 plus 0 less than or equal to 21? Is 0 less than or equal to 21? And that's true. So that means we are going to shade back towards 0, 0. Well, now we need to look, where is the shading for this system? If I want to take a look at the shading for the system, I'm looking for the ordered pairs that are going to be below the blue line. So we're talking about below here, we're talking about being above the dashed red line, and we're talking about being left of the purple line. Well, those ordered pairs are going to be the points that show up inside this little region here. So I'm going to darken this region as best I can to make sure that it is obvious that our solutions are coming from in here. Next up, we want to tackle the idea here that it is asking us to let me try that again. It's asking us to test whether or not, I'm going to just slide this off to the side, whether or not 1, 7 is a solution. Well, multiple ways we can do that. We can test whether or not 1, 7 is a solution by taking x being 1 and y being 7 and plugging it in to the first inequality, the second inequality, and the third inequality. It must be true for all of them. Or I take a look at the graph and say 1, 7 is talking about this point that's up here. Is 1, 7 in my shaded region? And I can say no. So I know it is not a solution. I'm going to pick a different color here. I'm going to go now with 3, 0. And if I take a look at 3, 0, 3, 0 is this point right here. Well, if I take a look here, 3, 0 is not inside the shaded region, but 3, 0 is on a solid line. It's also on a dashed line. And it's also, if I take a look, it is below the blue line. So I know that definitely 3, 0 is going to satisfy the first line. If I would like to, I can check whether or not it satisfies the second line. So how do I test that? I take 3 and plug it in to that second inequality. And I get, is 0 greater than negative 1/3 times 3 plus 1? Is 0 greater than negative 1 times, negative 1/3 times 3 is negative 1. Negative 1 plus 1 is going to be 0. And is 0 bigger than the number 0? And we know this is false. So right away, once we have shown that this is false, we know that then this is not a solution. Last but not least, let's take a look at, let's go brown here. Negative 1, 3. Negative 1, 3 is this point right there. Well, that point there is definitely above the red line, right? Does everybody see there? It's above the red line. It's left of the purple line, and it's on the blue line. If we're not sure whether or not that satisfies being a solution for the blue line, well, let's test it then. So if I want to test this, we're going to test it into that blue line. So we're going to take 3 and plug it in, and we want to know, is 3 less than or equal to 3? Well, 3 is not less than 3, but 3 is equal to 3, so we know that this is true. So what that means is that satisfies being an inequality for the top inequality, a solution for the top inequality, a solution for the second inequality, and a solution for the third inequality. So here we can say yes, it is a solution. As we move to problem number 4, it says, we are taking a test, which consists of type A questions and type B questions. It takes 3 minutes for a question of type A. It takes 6 minutes for a question of type B. The total allowed minutes is 60 minutes, or less, of course, and you may not answer more than 6 questions. Well, we're going to read that through once. We're going to read it a second time. And we know that the unknown things we're dealing with is how many of each of these questions that we're looking at. So I'm going to define my variable and say I'm going to go with A. I know sometimes we like to use X and Y, but that this is the number of type A questions answered. And I'm going to let B equal the number of type B questions answered. As I come through and read here, I'm going to also recognize that it says it takes 3 minutes for each type A question, 6 minutes for type B questions to be answered. So what that is telling me is that I have two rates here, right? So what I'm going to get here is that it's 3 multiplied by the number of A questions answered, plus 6 times the number of B questions answered. And that's going to be the number of minutes plus the number of minutes, which has to be less than or equal to 60 minutes. If I want to make my system here, the other inequality I'm going to look at says that I can't answer more than 16 questions. So that tells me that the number of type A questions plus the number of type B questions has to be less than 16 questions. Again, that there is our system. I do need to make sure that since we are graphing here, I'm going to put some labels on these axes. This is going to be the number of type A questions. Vertical axis is the number of type B questions answered. And now we have to figure out a scale. When we like to figure out our scale, I'm going to focus here on, because they're in standard form, if I take a look at that top inequality, the A-intercept is 3 times what number is 60, which is going to be, and I put X, probably be helpful here if I call this the A-intercept and the B-intercept. But yes, A would be 20 when B is 0. And if A is 0, then B is 6 times 10 is 60. If I take a look at the second inequality, I know that if I answer no B questions, the A questions would be 16. And if I don't answer any A questions, the B would have to be 16. When I go to graph this, I need to look and say, all right, I got 20 tick marks, 20 tick marks. I want to be okay counting by ones. And because I'm going to need to be able to write these scales in, I'm going to go counting only the evens. So 1, 2, and then 3 I'll bypass, and then 4. If you think you can write legibly enough and put all those, more power to you. And then let's graph this. 20, 0 is out here. 0, 10 is right here. It is less than or equal to, so we know that this is a solid line. And I do need to worry about shading, but if I test 0, 0, 3 times 0 plus 6 times 0 is 0 minutes, right? And is 0 less than or equal to 60? Answer is yes. So we're going to shade back towards 0, 0, where it was true. For the second line, we will test 0, 0 again, because 0, 0 will not be on our line. But we do have to recognize here that my x-intercept is 16, my y-intercept is 16. There is a second line, and if we test this, 0 plus 0 is that less than or equals to 16. Why this is true as well. So that means we're going to shade back towards 0, 0. Well, let's be careful here. When we are going to shade this, what I need to be careful is that I'm shading below the black and left and below the blue. So what I'm talking about are these points that are in here. So they follow along the black, and here's where it turns, and now we follow along the blue. And again, there are a number of solutions in here. We just want to darken it and make sure that it is obvious that we're talking about all these order pairs inside this region. All right. There we did. We solved the system by graphing it. We defined our variables, and now it says, can we state 3 combinations of type A questions and type B questions? Well, one possible combination that would work would be something like 6, 4. So I can say 6 type A questions and 4 type B questions were answered. I could pick another order pair. Maybe I pick something like 12, 2. That's 12 type A questions and 4. Sorry, that was not 4. That number that I said there was 2 type B questions. I could have actually used 12-4 because 12-4 is actually right inside there. And then last but not least, I could pick another one. Maybe I'm going to go with, say, 2, 8. Answers here are going to vary. These are just 3 possible combinations. And again, I put a sentence here to explain which ones were able to be answered. All right, that is a wrap for the video. Hope you guys enjoyed it, and good luck.